What's up, y'all? It's Thursday. You know what that means, right? Have you brought your snacks? Because it's also snack day. If you don't have your snacks, call your moms, dads right now and say, listen, it is Thursday snack day. We must have our snacks. Been enjoying a brown sugar, cinnamon Pop-Tart with nothing to drink. So I'm going to work through this Thursday with you, explain to you what we have going on. First of all, let me remind you of your spelling homework. I think today you're going to write sentences with your vocabulary words. Yesterday you would write sentences with your spelling words. Do I have anything on my face? How's that? Good. All right. All right. So just want to make sure you understand that. It's going to be a very easy day today. Okay? Easy day. Y'all say that after me. Easy. No. Easy. E-A-S-Y. No R was in it. Here we go. This is your Bible today. George Whitefield. Very, very good guy. Cool dude. Learned a lot from him. Studied about him in college. You're going to want to learn about him. Going to complete that Bible sheet. Going to learn about area of a square. Area of a square. Area of a square is very simple. Very simple. Remember, area is the amount of square units in something, okay? The amount of square units in something. All right, so if this square was 5 centimeters, then, okay, I could count all the way down and I would find out there were 25 of these squares inside there, which would mean that this was 25 centimeters square, 25 square centimeters. Okay, I also can employ our new A equals length times width, 5 times 5. Okay, now you have one more formula you can use for a square. Area equals side times side, or side by side. Woohoo! Let's go right side. Oh, not that kind of side by side. Side times side, not side by side, Justice. Side times side. Okay? Since every square has the same amount of sides and the same value in each side, in other words, if one square is 5, one side of a square is 5 centimeters, then all 4 sides must be 5 centimeters, because a square is not only a quadrilateral, it's not just a parallelogram, it's not just a rectangle, it's not just a rhombus, it's not just a polygon, it's not just a closed figure, it is a square as well, which means all 4 sides are equal, all angles are equal, all angles are 90 degrees, and each side means the same thing, which tells me I can just multiply one side times itself. So the area of a square, side times side. Side times side. So you're going to need to know that formula. Okay? Pretty simple stuff there. Squares are easier than rectangles. And I think you'll be fine with that. So what I'm going to ask you to do is stretch for me. And we're going to go through the rest of this science lesson. I know it looked like y'all were falling asleep last time I was doing my science lesson. Hope you have your snacks ready. We're going to learn. Did y'all like the Blue's Clues joke earlier? If you didn't, I was going to say we just got a letter, but I decided not to. It would require some singing. Your parents might watch this, and we don't want that. Now, let's talk about work and power. Work and power. There's a difference between work and power, so let's talk about it. Work is the use of force to move something. Okay? Some of y'all don't like that word work. I just now moved this. May not be a big deal to you, but I had to exert force, had to work, had to cause it to move. So I exerted force on it. Anytime you ride a bike, walk, throw a ball, anytime you do something like that, you perform work. Okay? Now, power is the amount of work done. Excuse me, that's allergies, not the coronavirus, and you cannot get it from me because you're in front of your phone and I'm behind my phone. Isn't that good? There's a invisible barrier between us. I could cough into your camera, you still wouldn't get it. So anyway, power is measured in watts. Okay? Power is measured in watts. That tells us how much work is being done for a unit of time. Okay? 1 watt is equal 1 joule of work in 1 second. 1 watt equals 1 joule of work in 1 second. Okay? So you'll notice that on your study guide. You don't have to get into detail. Watts and joules are measures of work. We're measures of power. Measures of power. Now, we're going to talk about machines for a moment. Simple machines. You've learned these before. Mr. Morrow taught them to you. I'm going to teach you six simple machines. First of all, a pulley. A pulley. Probably seen a pulley. Like this. A pulley does not increase force, it changes direction. Changes direction. Okay? As I turn this, it turns that. Okay? That's a pulley. A lever increases the force and decreases the distance. Okay? Draw you a little closer to something. And increases the distance and decreases the force. Increases the force and decreases the distance. Now, an inclined plane reduces the force needed to move an object. Okay, trying to think of an example on the cuff here. Reduces the force needed to move an object. So if you can raise it up. Okay. Now, very similar as a wedge. A wedge you put in an object in order to split an object. So let's say that I wanted to split that. I put a wedge shape something and I hit it just like we split a tree with a wedge shaped axe or a splitting maul. Okay, a screw changes the force of direction to a turning motion just like we do now with a screw. That's how a screw goes into wood. It doesn't go straight into wood, you turn it. As it turns, it gets farther and farther down. And then a wheel and axle changes a twisting motion into a downward force. You have weight on top of an axle, and you actually can roll that way. So just think about those. You don't have to know a lot about those. Not very simple. Very simple right now. We're not trying to get into detail with things. Hard to do pictures a whole lot. Anyway, those are the 6 simple machines that perform work. Okay? Now, think about compound machines. Sometimes we have machines that do 2 things. Think of a water faucet. Okay? The handle of a water faucet is a wheel and axle. Turning the handle. Okay, on the water faucet. Alrighty? There's a screw inside the handle that creates downward force. So, screw it. That absolutely opens it up. Okay? And then the washer inside is a wedge. When you go back up and it tightens up that washer, shuts it off. You go back down, releases it. Okay, so there are 3 simple machines in just a simple water faucet. I want to go down to motion real quick here and Carrie talk to you about these 2 things. Very simple, position and motion. Position is an object's place or location. All right, the position of this is right here in the air between my fingers. Okay, position. All right, motion occurs when an object's position changes. Okay, and motion depends on a frame of reference. Understand that for a moment. Okay, so imagine if I'm just reading a book and someone observes me reading a book. Am I moving? Am I reading the book? Doing both of those, right? Okay. Now, let's say the book wasn't moving though, right? The book is in my hands. Give an example. Holding the book. Is the book moving? No, not except for when I twitch or move here. Now, let's say I get on a train and I'm riding down on the train. Train's going 50 miles an hour. I'm holding the book. Is the book moving? Good question. I'm not moving the book. The book is moving. An outside observer is going to watch this book go right past him along with me. You see, I'm not moving the book. The book's moving with me. Okay? And so that's how position changes. The motion depends on frame of reference. See, the book technically isn't moving, but it is moving to the outside observer if I'm on a train. Now, in the same way, we're all moving right now as the Earth spins on its imaginary, the invisible axis. As it spins on that axis, we're all moving. It just depends on the frame of reference, okay? Speed and velocity. Speed is the measure of the distance an object goes in a given amount of time, and velocity is the object's speed in a particular direction, okay? Very simple definitions here. Acceleration is a change in velocity. Okay? If you slow down, it's called deceleration. So you accelerate, you increase your velocity. Velocity is your speed. You slow down, and it changes. Okay, it goes down. And then momentum is a measure of how hard it is to slow or stop something down. In other words, you've heard this before. Can't stop me right now. I've got momentum going in my favor. Okay? Momentum is how hard it is to slow something down. The more momentum you have, the harder it is to slow down. Imagine trying to stop a train. It has a lot of momentum. Okay? And by the way, the greater the velocity, the greater something has momentum. Okay? The faster a train goes, the more momentum it has, which means it'll be that much harder to slow down. It'll take that much more force to slow it down. Okay? I know that hasn't been a great science lecture. I've been debating on what to do with science and social studies. I'm going to hold on the history part until I absolutely have to teach it, because I like for us to be in the classroom to discuss that. We've got some stuff coming down the pipe here shortly, but we'll see how it goes in the next few weeks. But I think it's been great to be with you guys. Look forward to seeing you guys again tomorrow. I hope y'all have a great day. Thank you.